We have Ahmed. He's actually passionate for and AR, as well as virtuals and IoT, as well as Kenneth, who is actually a research scientist from NIE. So we're going to talk a little bit about thinking about the new norms today with COVID-19 as a response. So we're really excited to also bring them today to share with us a little bit about where we can think about social distancing, very similar to what we had a topic earlier, right, from the first talk we had with TIE. So we're going to actually have a nice understanding of this whole new norm today, together with what Ahmed and Kenneth are going to share. So with that, over to you, Ahmed and Kenneth.
So Ahmed and I are from the National Institute of Education. And over the next few minutes, we'd just like to share with you a project that we've been working on together with teachers from some secondary schools over the past few months in Singapore, specifically since March, with the imminent onset of what was known here as the circuit breaker, or otherwise known as a general a lockdown on movement to prevent the spread of to reduce the spread of the virus. So to tie in with Chia's earlier session, since Terence made the connection already, as we know, social distancing is a relatively new habit for each of us to need to invest the effort to develop. And even in the best of circumstances, developing a new habit takes time. But under the current climate, basically, we tend to need all the encouragement that we can get. And sometimes, I mean, there have been instances reported where, of course, that members of the general public may or may not necessarily understand very well or relate to the effort needed to practice these socially responsible habits. So what we have been working on with some schools since March is that there have been different ways in which to encourage or enforce distancing, some of which are more practical than others. And so we have, these examples, not necessarily meant to be very frivolous, but just basically to give some illustrations on how people across the world have been trying to respond. So, for example, we have this photo taken from a school in China where the children are wearing hats which kind of resemble traditional Chinese hats, which is a good thing because they've appropriated a cultural design to modern day circumstances. Here in Singapore, if we visit the schools, we generally find signs to encourage students, such as this one here, and the problematic that the teachers who approached us to help them collaborate on the project were trying to address is that sometimes children and students, young learners, they will do as they're told a lot of the time, but they're not necessarily buying. They're not necessarily doing it because they buy into the message, but more because someone in authority or the teacher, someone they trust, is telling them to do so. So essentially, what we've been working on is a design of a learning environment which helps young learners and children to develop a more authentic understanding of the need to practice social distancing of their own accord. So essentially, the trajectory that we are trying to embark the students on is that of from embodied interaction to everyday interaction through theoretical foundations in the work of game-based learning, which we need not necessarily go into today. Yeah. So again, in terms of advice from psychologists with regards to learning in the time of COVID, there are such exhortations to make the link between play-based learning and the development of socially responsible dispositions. So what we did was we developed a two-part project. The first part being an embodied experience within an open source virtual environment, which was kind of like designed to resemble aspects of Singapore to help them to help them make the mental link between their interactions in the environment and subsequent real world interaction. And these interactions, from time to time, the avatars have color coded this appearing around them to indicate to give them a visual augmentation of what constitutes safe social distance. Because as we know, each individual's understanding of what constitutes social distance is tacit to ourselves, and we may end up encroaching into each other without necessarily knowing it. So as I said, the intervention has two parts. The first part is an embodied half, and the second part, as the students explore the environment, unbeknownst to them, there's actually a virtual virus being passed from one to another, somewhat similar to the zombie pandemic games or simulations that some of you might be familiar with. And the system in the background keeps track of their interactions and of the virus in terms of how it's being diffused, and assigns each interaction a randomized value depending on the degree of infection which the teacher wishes to explore. So for example, if the teacher wishes to explore with the students an extremely infectious scenario, then the probability of being infected would be higher with any given interaction. So we are able to, so the teachers and the students at the end of the activity are able to access these spreadsheets of data from the interaction as web-based dashboards. Yeah. So let's see. So to kind of like to summarize what I've been saying so far before I hand over to Ahmed, the two parts to the interaction to the project an embodied half, firstly, in which the learners the learner focus is on their self-directed agency so that they can take ownership of their exploration, as well as to give them a visual augmentation of safe radius. This addresses the real world problem of when we ourselves go out outside our homes into, say, the shopping centers or the malls, we don't get immediate feedback on our decision making and behaviors, and we only get the feedback in the form of case numbers the following day. So there's a time lag in the real world between our decision making and the feedback on our decision making. So by doing this, by designing the project in this way, we are trying to address this particular time lag problem. The other problem related to that is, of course, not only is there time lag, but the feedback is non-particularistic with respect to the individual's decisions. So in other words, the feedback is, regardless of which country we live in, the feedback is basically a summative regional statistic and not particular to any given individual's behavior. Whereas with this, since with the second dialogic half, where the students and the teachers can get access to their particular data interactions, they can get this level of fine-tuned feedback. Yeah. So I think that's about it for what I want to say. Just to give you an understanding of basically this is taken from a class back in July. There for those of us who are familiar with Singapore schools, there are typically about 40 students per class, but this one shows a class of 20 because the other half of the class is in another room. And basically what the students do is they explore the environment and they have their guiding worksheets provided by the teachers. And after that, they have either their group-based discussion or their whole class discussion as mediated by their teacher. Okay, so thanks very much for your attention. And I'll hand over to Ahmed now. Ahmed will be able to give you a brief demonstration of the environments in action. Yeah, thanks. Need to stop sharing my screen, so I shall stop sharing my screen. Yep.
So hello everyone. I'm going to share my screen because there's a number of things I want to show you. I hope everyone can hear me and see my screen. So what you're seeing right now, assuming everything is okay, what you are seeing right now is actually my view in the virtual environment. So you can see there's a crowd of avatars in front of me. You can see there's a HDB block, there's a few shop houses. And just to give you a brief background in this environment that you're seeing, and hopefully it's not too laggy so that when I move around you don't feel sick and stuff. We're using a open source virtual world server called Opensim, which is basically, it started as a clone of the old virtual world Second Life, which is still running. Opensim is a open source offshoot, so you can actually deploy your server on your own computer or your own laptop even. It's fairly lightweight for what it is. And we've been using it in schools to conduct different types of lessons over, I would say, the past 6 years at least, 7 years at least. And this year, because teachers approached us, we had the opportunity to try doing something to get kids to get a better understanding of the pandemic. So let me show you what the activity looks like. I'm going to shift the view over to my this web interface on the right, which actually shows what the teacher's view would be when they want to start the activity. So the teacher can actually select one of the students who's logged into the environment to be patient 0, the initial infected person. I'm going to select myself, and they can select the probability of infection. So as I move this number over here, you can see the probability on the right changing. I'm going to set it to the most infectious, about 16.7%. And because this is going to be a fairly short demonstration, I'm going to set the cycle time to 30 seconds. Now, what cycle time means is that this activity takes place over 5 cycles. During each cycle, students can freely walk around the environment and mingle. And as they pass by other avatars, there will be a chance of infection spread if they're passing by patient 0. Of course, they won't know who patient 0 is. And at the end of the cycle, we update the list of new infected avatars and then repeat the sequence of students walking around and potentially infecting each other. So let me start the simulation because that'll be clearer than me just talking about it. Now you can see in the environment, all of the avatars, including mine, have this green ring around us. That signifies that we are a safe distance away from each other. We set it to 2 meters here. Now you see that avatar has just walked a little bit closer to the other avatars there, and now their rings are all red to show that they're all a little bit too close to each other. And if I kind of hang around near them, Oh, and you can see a little message here saying stage 1 has ended because I set it to just be 30 seconds. Typically in a classroom, the total activity length might be 30 minutes to 40 minutes, which means the cycle lengths would be a little bit longer. So that gives students the opportunity to wander around the environment, potentially engage in some activities like going on a scavenger hunt or doing some day-to-day tasks, basically. So I've hung around these 3 a little while. Hopefully there's a chance I passed on the infection. I think I'll hang around these folks. And because this is a this virtual world, we've found that it's relatively easy for students to get into this because a lot of students are familiar with online 3D games. A lot of them, when they see this, immediately make a link to Minecraft or Roblox. So like moving around is very natural to them, and trying out stuff in an environment like this is pretty natural. So it's not hard to get students to engage with an environment like this. And typically the first time we get students to try this out, we don't tell them that there is a virus simulation going on in the background. Of course, they'll notice the little indicators which indicate the social distance between them and the other avatars in here. And they would wonder, okay, like, why do we have these things in here? But we leave it to the end of the activity to actually tell them what's going on. And once this thing ends, you'll get a chance to see the results of the simulation as well. But before that happens, let me switch back to the teacher's point of view. So while the simulation is going on and the students are walking around engaging in game activities, the teacher, meanwhile, can take a look at what's going on with the simulation. They can see which cycle we're on now, and they can see who has been infected. So as patient 0, I've done my job pretty well. I've infected everyone except A22 over there, so I'm going to hang out with them and see whether I can pass on the infection. And the cycle is about to end, and unfortunately I did not pass on to everyone, but as you can see, from a virus spread point of view, it worked out pretty well. So once the simulation ends, all of the students get a chance to see the results. And if you can see my URL at the top here, which I will actually share in a little notepad too. If you want, you can actually get on your browser and just check out this web page so that you can see what happened for yourself. So students will get a chance to look at this too. I'm just gonna put this on top. Here we are. So yeah, basically once the simulation ends, there's a big reveal. The students find out, okay, there was a virus simulation going on. When they see this page, they can see, oh, I was infected or I was not infected. If they click on their name, say I'm going to click on this student's name, they get to see a list of results which shows exactly what happened. And if they were infected, they get to see at what point they were infected. In this case, this student looks like they were infected around cycle 2 from an interaction with this A21 avatar. These avatars have numbers because they're pre-generated avatars that we created for use in schools, but it's possible also for users to just log in with their own accounts and things, in which case you get unique names. So once they get this, it's up to the teachers and the students to kind of make sense of all this information. We've had this run in some maths classrooms, in which case teachers would tie this to probability and statistics, but we're also planning to do this in other subjects where you might be focusing a little bit more on social behaviors in the environment, like what did you do in the environment which put you at risk of infection spread, things like that. So let me maybe move back a little bit and talk about this platform that we are using and how it works, because I think what's interesting about this is that we conceptualized this around March, and we were able to get this prototype up and running by May, basically. And the reason why we're able to do that is that we're leveraging on an open source platform that's pretty robust. Opensim has been around for, I think, a decade or so, maybe more than a decade. It's one of the, I think it's one of the older virtual world open source platforms available. And one nice thing about it is that it includes a scripting language, which is built in. Oh, another thing, it also includes building tools. So that's partially why students make a connection to Minecraft, because, for example, everything that you see in this environment has been created using built-in building tools that everyone can access. Like anyone who logs into this environment has access to building tools. We also have access to scripting tools. There is a scripting language in here which is fairly similar to JavaScript. And it lets you put a script inside any object in this environment. So the way the simulation actually works is that there is this object called the data server. It's going to zoom in on this thing here, which actually processes all of the calculations regarding, okay, let me pull this thing up so you can see something that's going on here. So this data server actually processes all of the calculations for what happens when one avatar walks next to another avatar. And this thing here, there's actually a memory cell. There you can see now. There's actually one memory cell per avatar which stores the state of like whether they've been infected or not, and what was the history in terms of all the logs. So everything is done within the environment, and then we generate a web page to actually be able to access it from our web browsers. So that makes this platform pretty good for doing prototypes, proof of concepts. The only limitation here is that you can't really scale it up to hundreds of users, but for a school context, that's not really a problem, because typically you're doing it with one class for 40 plus people. Let's see, I think at this point, we're probably good to go to questions.
All right, thank you, Ahmed. All right, so just looking at the Q&A, right? Thanks so much for sharing. I think there's a couple of questions that has been posted across. Let me just share that with you here, and it'd be nice if you could answer that, live as well. So there are in fact 4 questions for you. First of all, is there a web page or website for this nice projects? Right, that's the first question. The second one is, what's the app that's being used for the 3D virtual environment? Do you want to take these 2 questions first, Ahmed and Kenneth?
Sure. I'll type the URL for the first question, and in the meantime, while I'm doing that, Ahmed can talk about the second.
Right. So the platform that we are using for this, there's 2 parts to this. Basically, in terms of the app, you have the server application, which I mentioned, called Opensim, and then you have the client application, which you use to access the virtual world. The client application is called Firestorm, and it's the same. Yeah, there are a number of different client applications which you can use to access Opensim servers. It's a bit like web browsers. You've got a selection to choose from, but Firestorm is one of the popular ones. And if you Google it, I think you can find the project page. It's called the Firestorm Viewer, basically. And as for Open Simulator, be careful when you search for it, because there are 2 Open Simulator projects, and one of them is like a project which is modeling like muscles for like biology people, basically for doctors and stuff. Yeah. But so it should be pretty easy to tell the 2 projects apart, though.
Cool. Thanks, Ahmed. Yeah, a couple more questions just came in. I mean, there's some time now. Let's see whether we can take some time to go through them. So I think Rabadak is asking, hey, can we change the head to the actual head of the people that are actually streaming the video? And can you also call a public internet API from the script?
For the first question, I think that would be maybe possible, but a little bit tricky with this software. You'd probably have to dig into the server code and add some new functionality. It's not quite a built-in thing to dynamically change the face of the avatar to match the feed from the webcam. So practically speaking, I would say it's possible, but it's a non-trivial task. As for web APIs, yes, because we're dealing with a scripting language which has some webhooks, it's possible. For example, if you wanted to display information from web sources within the environment, that's pretty easy to do. You can pull in information from databases and display it. I'm not sure if that's quite answering your question, but yeah, it's possible to put in some real-world data into the environment, basically.
Sounds good. Thanks, Ahmed. Just one last question, I believe that came up. So do the students actually, are they aware that their data is being monitored and collected?
Yeah, I'll take this question. So yes, this project is under the protocols of the ethics board of NTU as well as the MOE Corporate Research Office, which oversees learning interventions in schools. Yeah.
Right. Cool. Thanks, Kenneth, and thanks, Ahmed. Right. So cool. I think just wanted to call out that SORBET is a great project that you guys have just shared with us. It's really being designed to help nurture socially responsible behavior, and I can see that happening with this very fun gamification way of doing it, and how to develop the habit of social distancing. Right. So in case you guys haven't called out earlier, I just want to share that Kenneth has been teaching since 1990 as a geography teacher. His experiences with coding actually were with BASIC and Apple II, right, and Casio programmable calculators as well. And as for Ahmed's professional background, he's actually with game design, by having a passion for exploring technologies like AR and IoT for authentic learning. You can see how they come together really nicely, right, to bring pedagogy and gamification as a feature. So that was a great session. Thanks so much to both of you, Ahmed and Kenneth.